Every star you've ever seen, bright, distant, powerful, begins its life quietly, shrouded in gas and dust as a protostar. This is a story of how gravity sparks the furnace of fusion and sets the universe alight. A protostar is a young forming star, not yet hot enough to ignite hydrogen fusion in its core, but already pulling matter inward heating up and glowing in infrared. It's the intermediate stage between a dense clump in a nebula and a fully developed main sequence star. Protostars form deep inside molecular clouds. When a region becomes dense enough, it collapses under its own gravity triggered by disturbance like nearby supernovae. Conservation of angular momentum causes the collapsing cloud to spin, flattening into a round disk. Several fundamental laws guide the evolution of a protostar. Gravity pulls matter inward. Conservation of energy causes the core to heat as it compresses. Hydrostatic equilibrium begins to form through though not yet fully stable, and radiative transfer moves heat outward through convection and radiation overlay. Though fusion hasn't started, the protostar heats up to thousands of kelvins due to gravitational compression, a process known as the Kelvin-Holtzmann mechanism. Temperatures can reach to 2000 to 3000 Kelvin, glowing red in the infrared spectrum. As the protostar grows, it pulls material from the surrounding accretion disk, but excess angular momentum is rejected as bipolar jets, powerful outflow blasting into space along the pole. These jets regulate mass and shape nearby environment. The protostar becomes true star when its core reaches 10 million Kelvin, hot enough to trigger hydrogen fusion. Though protostar proton chain. This is a star ignition point. It enters the main sequence and begins a new life of radiance and stability. Because they are hidden in dense cloud, we observe protostar mainly in infrared and radio wavelength. Space telescope like James Webb telescope. The hidden growth each image captures a star's private beginning. Studying protostar helped us answer fundamental questions. How do stars gain mass? How do planetary systems form around it? And what determines whether a star will become a red dwarf or a giant? In protostar, the universe whispers its blueprint. So, this is how a star, the giants that ignite our universe, are formed, their beginning. What determines their end? How will they end? Where did they start? And the most incredible part, the death, the shock wave of one star gives birth and